So let's talk about chain rule. Chain rule is what we use when we're taking the derivative of a composition of functions. As if one function is inside another, like a math version of like nested bills or something. So then it would be like, you might see like f of x, 3x plus 1, and there's like an exponent at the top. You're not just dealing with the power rule, you have to take care of the outside and the inside. And that's what the chain rule is. And then here's like the chain rule formula. So f of x, g of x, h of x. Then you have to do f of x equals g of x, h of x like that, times like that. So I guess in plain English, like take the derivative of the outside, leave the inside alone, then multiply the derivative of the inside. And so like we come up and work this out. So if we do the example, I don't know that, but we can do like f of x equals 2x plus 3 to the 4th. So step 1, you want to identify your outer and inner functions. So your outer function, not g of u, it's just going to be e to the 4th. So this is your outer function. So this is e to the 4th. And then your inner function, which is h of x, is going to be 2x to the 3rd. So your second thing you want to do is you want to take the derivative of the outer function. So you want to use the power rule. So we have u, so we have 4. So again, you're taking the derivative of 4. So what do you do with that? You're just going to put it down there next to the u. So then g prime u is just going to be 4 u to the 3rd. So step 3, you want to leave the inside alone. So then we have, let's write this a little bit better. U of x, h of x. So again, we have u. U is this here. So it'll just be 4 or 2x plus 3. Remember, 3 is up here. And then now we want to take the derivative of h of x on the inside. We want to take the derivative of the inside function. So the derivative of the inside function is just 2. So after that, we can do 4x, 2x plus 3 to the 3rd times 2, take it out. And again, because this is also a constant, bring it over here. So then you have 8x minus 3. That's the 3rd. Alright, so now that we did that example, let's do a practice problem. So we can do 5x second minus 1 to the 6. So step 1, you just put it through what's on the outside, what's on the inside. Take the derivative of the outside with the inside still in it, and multiply the derivative of the inside. So give me a second to solve it, I guess. So let's do this. Me personally, I like to go different ways, but we can do the exponent first. So we're just gonna change this. It's gonna be 5. It's gonna be 5. And there's gonna be 6 right here. So 5 squared minus 1. Take the derivative of the inside, which is going to be 10x. I think it's like that actually. So it's be 6, 5x squared. And then we have 10x. Don't forget to always break down your exponent. And then just combine them. Then you're just going to have 6x 5x squared minus 1. And then do a second problem. So then you can have a problem could be like a harder one. Like 4x to the 3rd plus 2. So probably think like Oh, where's the power? There's always going to be a power because you're always rewriting. So then we fx. This can always be reversed because remember, when we did it previously, we had it to 1/2. So you do parentheses 4x to the third plus 2, and then square root is just 1/2. So after that, I'm going to take the inside and the outside functions. So let me go back to writing ajax. Because that's easier. 4x to the third plus 2, and then our outer is g. Is a gu. Half. So when I take the derivative of an outer function, which is just going to be this opposite derivative, so it's just going to be 1/2 u, negative 1/2. And then you want to rewrite it, so then it's just going to be 1/2 x to the third plus 2 minus. I'll have to take a derivative of the inner function, which is h of x prime, which is just going to be 12x squared. Like that. So now what we know, we have 1/2, and then what was on the inside originally, 4x third plus 2, and that's just going to be times 12x to the second, which is just going to equal, if you want to rewrite it properly, 12x squared. Remember, we still have the 1/2, there's a negative right there, so then that's going to be flipped. It would be 4x third plus 2. And yeah, that is the test here.